All right. So next, real quick, this is super similar, so I'm not going to spend too much time on it. Let's look at the product. So the product is just like the series we just talked about. The series, the sigma notation thing, the series sum over a sequence, products multiply over a sequence. So what I mean by that is the product multiplying over this sequence would be AM times AM plus 1 times AM plus 2 all the way out to AM minus 1 times AM. So that's the product going over all these. And just like how we had sigma notation, we also have big pi notation to simplify talking about this. And the way that we can write this in a different form is write capital pi, which is where this is lowercase pi. It's curvier and smaller and more famous. But his big brother, capital pi, he was pretty cool too in high school. And the way you do that is just like sigma notation. You keep the range, m equals I to n of ai. So here, again, I runs through integers from m to n multiplying. Is it a little blurry? What's happening? That's better. So for example, let's say we had, that's a good example. Oh, that's interesting. Let's say we have pi from I equals 3 to 6, or the product from I equals 3 to 6 of -2 raised to the I. A little weird. What this would be is you just run through every integer in the range 3 to 6 and do -2 times that, -2 raised to that integer, multiply them all together. So first you want to do -2 raised to the 3. And the next integer after that is -2 raised to the 4, and -2 raised to the 5, almost added, and then -2 raised to the 6. Instead of adding everywhere like we did in the sum, we multiply between all of them. In this case, what would that be? So -2 cubed, well, remember when you cube a negative, when you raise a negative to an odd power, you can pull the negative out. So this is going to be the same thing as -2 cubed. So the difference here, I'm doing 2 cubed, making a negative, rather than doing -2 cubed. And then when you raise a number, a negative number to an even power, it just becomes the positive version of that. So this is just 2 to the 4, raising it to an odd power here, so we can take the negative out. And then this is raised to an even power, so we can just get rid of the negative. So we get that. And then this negative and this negative, since they're all being multiplied, will cancel out each other. So that's just 2 cubed times 2 to the 4th times 2 to the 5th times 2 to the 6th. And then by our exponent rules, right, if we're multiplying a bunch of things with the same base, we can add the powers. This is 2 to the 3 plus 4 plus 5 plus 6, which equals 2 to the, what's that? 7 plus 11 to the 18. And once again, this is the complicated part. I hope the actual thing I'm trying to teach you right now, which is what products are, I hope that makes sense. Any questions? Cool. Feel free to ask a question anytime if one comes up. But now let's do a different example. We're going to go backwards again real quick. So, yeah, let's go backwards. So let's say we were doing, let's say we want to write log of 1/2 times 2 log of 1/3 times 3 log of 1/4 times 4 log of 1/5. And let's just say that log is log base e, the natural log. So how do you guys think we should proceed?
Can we write it explicitly?
Yeah. I think we should do the same thing we did with sums, right? First look at the sequence and write it explicitly. How about that? Same logic. So let's see here. Let's first just write the sequence out. The sequence that we're multiplying over is log 1/2, and then 2 log 1/3, and then 3 log of 1/4, and then 4 log of 1/5. Wait, I want a comma there. There we go. So this is the sequence you're multiplying over. And so the big thing we have to do, the only big step, is writing this explicitly. Because once we have that, we can easily translate that into the product. So, once again, I want you to figure out like what the heck AI is for some index I. And we also have to choose where we want our index to range from. So what do you guys think here? What's the pattern in this sequence?
Is it like I times the log of 1 over I plus 1?
That's absolutely what it is, Lauren. It's not just like it. Thanks for being humble, though. Yeah, it's just that. Yeah. So the pattern you can see right here in trouble. For those of you at home, if you're in trouble, I guess we're all at home. Oh, if you're in trouble, you can see that, okay, every time I go, like every part of the sequence, it goes 2, 3, 4, 5. So the bottom denominator is increasing by 1. Also, this is going to be multiplied by the sequence. And that's 2, 3, 4. Well, remember, multiplying by 1 doesn't change anything, right? So we could always add kind of like this. We can always think about a 1 being multiplied there. So once we see that, we go, oh, clearly there's a 1, 2, 3, 4 being multiplied there. So the thing being multiplied keeps going up by 1, and the thing on the denominator keeps going up by 1. But these are 1 apart. So just pick 1 to be your index I. Here, Lauren picked the thing on the outside multiplied to be I. And then that means that then the denominator is just I plus 1. But I hope if you do this out, you'll see it makes sense. Like, oh, for every ith element here, the value truly is I times log of 1 over I plus 1. I feel like it's one of those things where me explaining it makes it worse. It's like a joke in that way. And also it's fun. So, yeah. So, and then what's the range on this? Well, we got chat. 1 to 4, exactly, Camille, exactly. Start at 1, go to 4. That makes me feel good. That makes me feel very good that we're getting that. Perfect. So this also helps us get good at our sequences. But anyway, then what that tells us is that the log of 1/2 times 2 times the log of 1/3 times 3 times the log of 1/4 times 4 times the log of 1/5 is going to equal just the product as we multiply from this should have been I equals M. My bad. The left part here tells you what their variable that's running over is. The right one tells you where to start. And so I don't want M and starting at I, because it doesn't make any sense. There's an I here, what's going on? Yeah. Anyway, so I want I to start at 1 and go to 4. And at each step, I want to multiply the ai'th term, which of course is 1 over, or no, AI, or you said that, it's I times log of 1 over I plus 1. Any questions on that? Good, I hope that makes sense then.